Good morning students, welcome to Easy BTech, and today I am going to explain about the region bounded by the curves in double integration. Before that, please like, share, subscribe Easy BTech channel. And here the problem, that is evaluate double integral r xy of x plus y dy dx bounded by the curves y is equal to x square and y is equal to x. So the solution, so given curves. So what are the given curves here? Given curves are y is equal to x square and y is equal to x. Okay. So drawing the corresponding diagram related to these two curves. It is x-axis and it is y-axis. The first one, y is equal to x square, is here parabola. This is nothing but parabola. Okay. And y is equal to x is straight line which is passing through the horizon. So y is equal to x square parabola is like this. X square is equal to y. It's also passing through the horizon here. And y is equal to x is a straight line equation which is passing through the horizon. So now the region bounded by these two curves are this part. The region bounded by these two curves. Okay students, now we have to evaluate this region bounded by the two curves here. So before finding the region, so at first evaluating the intersecting points here, O and A here. So of course the O intersecting point is 0, 0 only. Now to get A point value, solving the given curves. They are y is equal to x square and y is equal to x. So okay, to get the intersecting point of A here, substitute y is equal to x value in this parabola equation. Then if y is equal to x, then x is equal to x square. Doing the cancellation, you will get the value of x is equal to 1. Again, if you are substituting x is equal to 1 in this condition, y is equal to x, then again you will get the value of y is nothing but 1. So hence the intersecting point is 1, 1. Okay. So now doing the integration here, then double integral r xy of x plus y dy dx is equal to double integral, do the multiplication xy to the both terms, xy into x, that is x square y, xy into y, that is x y square, and dy dx. Yeah, to do the integration we need limits here. So according to the evaluation of double integration procedure, y limits are as a function of x, then x limits are as a constants. If x limits are as a function of x, y, then y limits are constants. But here in this problem, I am choosing that y limits are as a function of x and x limits are as a constants only. Okay. So now using the given curves only, I am writing the limits here students, because the two curves was given here, y is equal to x square and y is equal to x. So I am writing here the y limits. Y limits are x square to x, and x limits are 0 to 1. Okay. See here students, this is the bounded region, okay, R1, and this is the lower part of the bounded region, and this one is the upper part of the bounded region. So for lower part, we get this curve shape by using the curve y is equal to x square. So then y is equal to x square as a lower limit, and upper part, this upper part you will get by the line equation y is equal to x, then upper limit becomes as a 1. Then x limits according to the diagram, this is the x coordinate and this one is the x coordinates, then limits becomes as a 0 to 1. Okay. So now I am doing the substitution of the limits, y limits and x limits, and doing the integration. So y is equal to x square to x, and x is equal to 0 to 1, and the integrand term x square y plus x y square. So at first doing integration with respect to y here, So because y limits are as a function of x, then doing the integration with respect to x here. Because y limits are as a function of x only, that's why it's compulsory first to do an integration with respect to y only. So integral x is equal to 0 to 1. So integration with respect to y, students. So x square is a common here, that means constant, and y is here, then y integration is y square by 2 within the limits x square to x. And again here x common, and here y square is there, and y square integration y cubed by 3 within the limits x square to x, and the next second integration have to do with respect to x after doing the simplification of this one. X is equal to 0 to 1. So x square by 2, students, these two I write here. So the next one, substituting the limits. Upper limit is x here, in the place of y have to substitute upper limit x, that means x square, and again minus x power 4 and plus x by 3 x cubed minus x power 6 into dx. So have to do the second time with respect to x. See here, students, y square is there, x square to x are the limits. For upper limit, in the place of y substitute x, that means x square. Y square is there, in the place of y if you are substituting x square, it becomes as a x square whole square. And third one, y cubed x square to x, upper limit x cubed, and again x square whole cubed will becomes here, because we are substituting x square in the place of y only. Okay, so now doing integration with respect to x here. Before that, doing the simplification of this total term. Okay, simplification, that is equal to integral x is equal to 0 to 1 x square by 2 into x square, x power 4 by 2. Similarly, x power 6 by 2, and x by 3 into x cubed, x power 4 by 3, and similarly the next term, x power 7 by 3 into dx. Now doing integration with respect to x here. Okay, before doing the integration, is equal to first one 1 by 2 common, student. For x power 4, integration is x power 5 by 5 within the limits 0 to 1, and here also 1 by 2 common, x power 6 integration x power 7 by 7 0 to 1, and again 1 by 3 common, x power 5 by 5 0 to 1, and again 1 by 3 common, x power 7 integration x power 8 by 8 0 to 1. Okay, then 1 by 2 upper limit, that is 1 by 5 minus 1 by 2 upper limit, in the place of x 1 substitution, and plus 1 by 3 and again into 1 by 5 minus 1 by 3 into 1 by 8. This is one terms substitutions limits. Okay, that means 1 by 10 minus 1 by 14 and plus 1 by 15 minus 1 by 24. Then finally you will get the answer as 0.05357. That's the answer of this question. Yeah, the next question is evaluate double integration R x square plus y square dx dy over the area bounded by the ellipse x square by a square plus y square by b square is equal to 1. Okay, now the solution. So this is the ellipse diagram here. Ellipse is symmetrical about the 4 axis. So on x axis minus a comma 0, and here on a comma 0, and again here, because on x axis the value of y is 0. So on y axis the value of x is 0, that means 0 comma minus b here, and here 0 comma b. Okay, students, minus a to a and minus b to b. So the ellipse equation, so given ellipse. So given ellipse is x square by a square plus y square by b square is equal to 1. So okay, so y square by b square, using this ellipse equation only, 1 minus x square by a square. So the LCM is a square, then a square minus x square. So the value of y square by b square is equal to a square minus x square by a square, and the value of b is y square is b square by a square into a square minus x square. So the value of y is here root of b square minus a square into a square minus x square. So b square by a square is there here, so root of b square by a square. So this term may also be written as b by a whole square, and square root will be cancelled. Then the answer is, and this value is nothing but here y is equal to plus or minus b by a into root of a square minus x square. Okay, so using the ellipse equation we find the value of y here. These y values becomes as a limits of the given problem. Okay students, so writing the limits here. So y limits are minus b by a root of a square minus x square to plus b by a root of a square minus x square. So because it is a evaluation part condition of double integration, y as a function of x, then x as a constants. So x limits are minus a to a, because the diagram on x axis the ellipse is like this, then minus a 0 to a comma 0, then x limits are as minus a to plus a here. You may change x as a function of y students, then y as a constant. Okay, so now the double integration of region was given in the question, that is x square plus y square and dx dy. So now I am writing the corresponding limits here. Y is equal to minus b by a root of a square minus x square to b by a root of a square minus x square, and integrand term x square plus y square dy and dx, and here x limits minus a to plus a. Okay, so at first doing integration with respect to y students, because y limits are in terms of x here. So in integration we are having one formula, minus a to a f of x dx is equal to 2 into integral 0 to a f of x dx. If the lower limit and upper limit are having the same values, and alternative, I mean the one lower limit is having minus symbol and upper limit is having the plus symbol for the same value, then we may write down the integration limits by taking lower limit as a 0 by multiplying with 2. So see here in the y limits, limits in integration minus b by a root of a square minus x square, I am writing the integrand term as a plus, then b by a root of a square minus x square and dy is there. Then if you are changing this lower limit as 0 here, then multiplying with 2, 0 to the upper limit as a b by a root of a square minus x square into f of x. So following that way here, so 2 into y is equal to 0 to b by a root of a square minus x square and x square plus y square dy. Okay, and here for x limits also we are applying the same procedure here. X limits. So x limits are as minus a to a f of x dx was given here. Then according to the procedure, 2 into 0 to a and f of x dx. Then here the limits are in terms of minus a to a. Then you may write down 1, 2 here and integral x is equal to 0 to a. Then again dx here. Okay. So we applied the formula, integral formula for both terms. That means for dy at the same time dx also. So now multiplying with these two constants. So 2 into 2 as a 4. Integral x is equal to 0 to a. Okay, now I am doing the integration here. Okay, x square, we are doing integration with respect to y, students. Then x square as a common here. Then integration 1 will be there and integral 1 is nothing but y here because we are doing with respect to y. Then 0 to b by a root of a square minus x square. And here y square is there. Y square integration is y cubed by 3. The same limits 0 to b by a root of a square minus x square and into dx. Yeah, the next step is substituting y limits here, corresponding y limits. Okay, now I am doing the substitution. 4 into integral x is equal to 0 to a x square. So upper limit only, students. That means b by a root of a square minus x square and plus 1 by 3 as a common. So in the place of y you have to substitute this value and again whole cubed also. So that means b by a whole cubed root of a square minus x square whole cube. So overall dx for total function dx. Okay, students. So next 4 into integral x is equal to 0 to a b by a into x square into a square minus x square and again b cubed by 3a cubed. So a square minus x square whole power 3 by 2 dx. Okay, how you will get 3 by 2 here? Root means 1 by 2 here. 1 by 2 into 3 is nothing but 3 by 2. Now to do the integration of this thing, this term here. So for this integration we are using the substitution method here. The substitution is like this. Put x is equal to a sin theta. Then dx is as a cos theta and d theta. When limits I am changing here. When x is equal to 0, theta is 0. And when x is equal to a, theta is pi by 2. Substitute the value of x in this function. Okay. So here the term here root of a square plus x square is there. So at first I am finding a square minus x square. So a square minus x is a sin theta. X square is a square sin square theta. So a square as a common. 1 minus sin square theta. Then a square cos square theta is the value of a square minus x square. So if you are finding root of a square minus x square here, then root of a square cos square theta, then square root will be cancelled. Value is a cos theta. Okay, students. So okay, now I am substituting the values here. Now 4 into integral theta is equal to 0 to pi by 2, substituting the values. So b by a, x square is there here. The value of x is a sin theta a sin theta whole square, and root of a square minus x square value is a cos theta, okay, and plus b cubed by 3a cubed, and a square minus x square value is a square cos square theta and whole power 3 by 2 and into d theta value. So dx value here, dx is a cos theta and again d theta, okay, yeah, and is equal to 4 into integral theta is equal to 0 to pi by 2. So one a will be cancelled here, then b a square sin square theta cos theta and plus b cubed by 3a cubed cos cubed theta into a cos theta d theta. So how you will get a cubed means here students, a square cos square theta is nothing but a cos theta whole square and whole power 3 by 2 is there here, then a cos theta whole square and whole power 3 by 2, then 2 will be cancelled. Final answer is a cos theta whole cubed, then a cubed cos cubed theta, okay, and 4 into integral theta is equal to 0 to pi by 2 b a square. Do the multiplication with a cos theta d theta. Already a square is there and a square into a as a cubed here, and b a cubed sin square theta cos square theta d theta, and integral theta is equal to 0 to pi by 2 b cubed by 3a cubed into a power 4 cos power 4 theta into d theta. So here a cubed will be cancelled, then 4 into integral theta is equal to 0 to pi by 2 b a cubed sin square theta cos square theta d theta, and integral theta is equal to pi by 2 b cubed, here students b cubed by 3, b cubed by 3, and the next a will be here, that is a cos power 4 theta and again d theta, okay. So now in integration using the formula, related formula for this one, even and odd formula, power values. So before that ba cubed as a common, 0 to pi by 2 sin square theta cos square theta d theta, and b cubed, that means ab cubed by 3 common, and theta is equal to 0 to pi by 2 cos power 4 theta and again d theta, yeah. So we are using the formula, okay. Now using this formula here, if m and n are even here, then 4 into b a cubed, m is 2 and n is 2 here, both are even. So applying the formula we will get the values as 1 by 4, 1 by 2 and pi by 2, and again plus b cubed a by 3 into, the second term is also applying this formula, here n is equal to 4, so that means 3 by 4, 1 by 2 and pi by 2, okay. Okay, now please multiply with 4 here, 4 a cubed b into 1 by 4 into pi by 4 and plus 4 a cubed a b cubed by 3 into 3 by 4 into pi by 4. So 3 will be cancelled and 4 cancelled, and here and 4 cancelled. Final answer pi by 4 a cubed b, and plus here also pi by 4 ab cube. So pi by 4 as a common, a cubed b plus ab cubed is the final answer. Thank you students. Please like, share, subscribe EasyBit.